Windows against Macs discussions after the talk. let's go EF Core and SQL Server, which is almost equally a controversial topic. And that's actually the reason why I want to talk about it, because I am one of the weird people that look at EF Core and says, actually, this is a nice technology. It solves all of my problems. It does have its own problems. But what I see is when everyone sees weaknesses of it, I'm like, but what if there wouldn't be? And then I think, how can we make it so? And I also discover through understanding the weaknesses of EF Core, I understand the strengths of SQL Server, and with it, also weakness of SQL Server. And I'm starting to then get a bigger picture of, hey, where can I do certain things the best? Now, this talk is kind of trying to be like the first part of how can you actually leverage EF Core with SQL Server more, because at the time that I started doing this, I was like, I'll probably do 1 hour and it will be fine. Then it was 2 hours, then it was 3 hours, then it was 4 hours, and then I was like, can I even fit this into 1 day? Because it's keep on growing, because EF Core has been surprisingly undocumented in terms of what it can do. And a lot of people say, I'll just do it in SQL, rather than asking themselves, hey, can EF Core actually do that? And hopefully, I'll give you some motivations on anyone who uses EF Core and tries to do more raw SQL to actually try EF Core to do those things, and maybe vice versa, see how can you make both of them better. So I am Jernej Kavka. You can call me JK. This is all of the socials over here. You can frequently find me at NDC conference. I've been like London, Oslo, Porto, Sydney, lots of different countries and cities. And also Brisbane Full Stack User Group Organizer, and also Global AI, the podcast. So if you're interested about AI, we're talking about lots of different topics, not just technical, but how AI impacts different areas. I am AI MVP. Ironically, I focus mostly on EF Core. And because day by day, I am a .NET and EF Core dev first, then AI developer enthusiast at night. So some of you might have heard about this talk, Common Mistakes in EF Core. I've done lots of variations, each of them better than the last. This one is specifically for EF Core. So this is irregardless of what database engines you're using. This talk is going to be specifically for SQL Server, and that's because most of the EF Core developers are using SQL Server. All right, so I'm going to start off with the log telemetry and tagging. I think this surprised a few people when I first showed them. I want to show that first, because if you have problems with SQL Server with performance, if you don't know what SQL is the problem, and you don't know which EF Core link query is causing that problem, you have a problem. And EF Core and SQL Server isn't the problem. It's the problem that you don't know where to even look at the things. And then the magic of SQL, which is going to touch on querying, joining, and grouping. But I'm also going to show you a thing that you're probably aware of, but didn't quite connect the dots, is how is the data represented in SQL and EF Core. We're not going to go too deep, but I'm just going to give you a few little pointers so that you might be able to start to understand why in certain area EF Core and SQL seem to work very differently. And last one is indexing. And I'm also the middle one. I have snuck in some content that hasn't been yet done in NDC Sydney, specifically for this user group. I was intending to do it in the next talk, but I was just like, what the hell, let's do a sneak peek. Oh, before we start, how many of you are using EF Core? Okay, about half a room. How many of you are using SQL Server? How many of you are like, I'll just write in a raw SQL, I want to do it in EF Core? Oh, we have only one, 2, 3 hands. Okay, surprising few. Well, I hope you'll like EF Core even more after this. All right, so why logging is important? I alluded a little bit before, but the thing is that with logging, you know what happened, why it happened, when it happened, and where it happened. So essentially, a web request crashed, and it tried to update a locked identity. It happened in Tuesday morning. Now, this is very important information sometimes, because in Tuesday morning, the accountants do invoicing, and they do a lot of them. So, maybe that's why it crashed. And where it happened, here we have update locked invoices, so I can actually look in the code and try to fix the problem. So this is why logging is important. This is why it can give you. And here is the application insights, where you can see the what would in this case be the exception. The exception is not really very useful in this case. It's just a system argument exception. We know it happened in afternoon, but this one is useful. So we have cannot change date start because invoice is locked or paid. So this is very useful information. And here is also where is the code. So this is what we want from our logs. But I'm going to show you a little bit more what you can do. This is going to be just a very high level way of how you can configure it. I'm not going to show you the details, but pointers of how to do it. Because what you want to do is you don't want to have this, at least not all of the time. You want to at least have in a staging environment where you can see the SQL queries, so that when something goes wrong, you can identify what went wrong. You can reverse engineer and then fix the problem. And by default, you'll see this. We'll just see, okay, it used this connection string on this server, database server, and this database. Not really useful. So what we can do is you can use the open telemetry. This is something that Microsoft now is pushing instead of you integrating, say, directly to application insights or New Relic or SIG. You can use open telemetry, and that one then can push all of the telemetry to wherever you want. It's open source. It supports a lot of things from ASP.NET Core, .NET, Java, Node.js, Python. So it's pretty good thing to have in it anyways. And how many of you have heard about .NET Aspire? We have a few hands. Well, if you use it with .NET Aspire, you get more features out of it as well. So nice feature to have. So how do we solve this? Is when you just install everything required for the, say you have application insight, if you install all of the required extensions, you're starting to get these SQL queries. Now, you can decide whether you want to have secrets in it, which means the parameters to the SQL. Now, if it's in production, you probably don't want that because, yeah, some people even say that the queries themselves can be sensitive, which in very limited cases can be the case. And in that case, try not to use it in production. But in most of the cases, this is fine. But yeah, you should review your data before just randomly open everything. So this is how we get the telemetry on SQL. Now, this telemetry that I've shown is just for the SQL request. It may not always connect to your web request, or you don't actually know the sequence of events, how it got to that SQL query. So next stage, what you can do is improve your .NET and EF Core logging. Now, if you have opened, I'll actually show it later. So here, if we add this part, Microsoft Entity Framework Core information, this will give you additional logs in your from the built-in Microsoft Logger, which over here you can see the actual select statement. And you can choose whether to include sensitive information or not. By default, that is disabled. What I usually do is if #if debug, then I enable sensitive information. If not, I just don't do anything. So when I locally debug, I have the privacy information because I need to know how to debug the thing. Once it gets out of my machine, then it's disabled. And yeah, here is, if anyone wants to follow the rules, we have some rules for best tracing. Now, this is very interesting because if you use OpenTelemetry, you can actually install the instrumentation for Entity Framework Core. I haven't had the pleasure yet to use it in one of my projects because I just recently got to a greenfield project with OpenTelemetry, and we're just about to start adding all of this stuff in. So just probably a week too late. But in theory, what this allows you to do is the same what I've shown earlier. Oh, sorry. Almost lost my microphone. What this allows you to do is, in theory, the same as before, but directly integrated into OpenTelemetry. It is currently in preview as well. That was about screenshot about 2 months ago. I think it's still in preview. Haven't seen any news about it, but hopefully, fingers crossed, it's already out. Now, this is getting a little bit more information from .NET. It gives you roughly similar than the first step, but the difference is now this is baked in with all of the things that happen, like your request happened, and all of the other things is happening, and here's the SQL that happened. So if Application Insight, for whatever reason, loses that thread where that SQL happened, there's a good chance that .NET will be able to tell you. But there's another way how you can make this work for both systems, where at least you can identify where that SQL happened in your code. And that is by adding additional context through .NET code that gets baked into the SQL query. And that's called EF Core TagWith. And the crazy part is this has been released in 2.2, which is like 2017. And what is the crazy thing is this hasn't been used a lot. But the power of this, you add this TagWith over there, is that it adds a little comment over here. Now, why is this powerful? Is because it's part of SQL. That means if you have a SQL profiler, you will see this. And I'm asking myself and everyone else, why wouldn't you want that? You know exactly from where the SQL query is coming from. Why wouldn't you want that? And you can even use SQL Profiler, you can use Application Insight, your Relic, Seek, whatever. You'll be able to see exactly from where this is coming from. And I'm still don't quite understand why people don't use it, but I think it's because they are not yet aware it exists. And I'm trying to change that. So more people are aware of this, because some people tell me, hey, this is a lot of work, yada, yada, yada. And then I tell them, here is a really bad bug. I opened the SQL, I saw it's exactly over here. I went to that query over there, made small fix, pushed the change, and I was done in 5 minutes. And I'll ask them, if I remove this part, how long do you think it will take to fix this? It's like, yeah, it'll take 5 minutes. I'll say, you know, this query looks awfully a lot like 20 other EF queries. How would you figure out which of those is this one? And I started to think, oh, Okay, yeah, I probably will take an hour. And this is why. Like, even imagine that you have like a super large query in a project where there's a lot of super large projects, where literally the only difference is which tables you join. Everything else at the top and the beginning looks the same. Now you'll have to look at the, somewhere in the middle is the difference, spot the difference, and then figure out which one caused that difference. This, no problem. But you'll say, hey, I'm a bit lazy. So you'll be like, you have TagWithCollSite, which what it does is it tells you exactly which file it is and on which line. But you know, I don't like this. You know why? Because first off, you know, in the beginning, you're doing lots of refactoring, moving things around, and line numbers changes between versions, and it's long. I don't like being that long. So what I prefer instead is a thing that I built myself, custom tag. I just call it TagWithContext, which you have optionally no parameters, but you can add a parameter if you like. And this is really, really cool because by default, what it's going to take is your class name, the function from it's being called, and the third optional parameter is the purpose. So what it does, it generates something like this. So you have class, method, and purpose. Now you not only know where it is, but what it's supposed to do.
There's a comment here saying not many developers are aware of the SQL profiler. It's not part of most C# devs or any .NET devs tool stack most of the time, unless they run into an SQL dev.
Oh, okay, yeah. Okay, so I just got noticed that a lot of people don't know what SQL Profiler is. It's a really cool thing that you can run, connect to your SQL server, and then you can see all of the SQLs that are, and all of the events that are happening on that SQL server, which is really, really good if you want to debug what's going on the SQL server without needing to you go through all of the logs on application insight, or maybe you don't even have logs, and you can just see the live traffic. And with this, you'll be able to see also the comments, which is really awesome. And this is the code. If you're interested, I can give you a snapshot of this after the talk, but it's not really that much. But this little code over here makes it so that I can just call TagWithContext almost everywhere, and where there's more than one link query, one EF core query in a method, then I put purpose. Or if there's a very complex query, I'm like, you know what, I technically don't have to write this, but for the benefit of the developers, I'll still write a little bit in it, because that now also serves as a soft documentation. People can look at that and say, ah, okay, I think I understand what this query is supposed to do. All right, so these, yeah.
So the profiler, could you run it in an Azure database, or does it have to be an on-prem SQL server?
So the question is if SQL Server Profiler can work on the Azure database. As far as I know, it does, right? Yeah.
Microsoft says it's deprecated and advocates to use extended events instead.
Oh, Microsoft says extended for the Azure database?
For the Azure database and
yeah. Yeah.
SQL Server.
But that's fine. Like, anyway, you can see the SQL queries. The main point here is that you can see the comments. If the tools changes, as long as they don't strip away the comments, you're good. There are a couple of tools, usually the ones that are geared toward performance, where they strip out all of the comments, but they also restructure the query itself for its own purposes, so that I think it's more about being able to match identical queries between each other. But in most of the tools don't remove the comments. All right, so once we have the logs working well, What you can then do is here I have a log from application insights. The cool thing is I can see it's in timesheet service, save timesheet, and what it does is emp time day any. So it checks if there's any time for that day. So people can now understand it just by looking at that. So this one is about getting a client, and this one is about timesheet billable type. So I can just look at this part, and I can understand what this is doing. And this is very cheap to implement. It requires just a tiny bit discipline, but so much easier to debug. And if that doesn't sell you, you can literally copy. You can go to this file, copy this part, and just Control F and find the place where you use that. It's so amazing. It saves so much time. All right, now hopefully I sold you on logs and telemetries, and hopefully you won't spend another weekend debugging a production because nobody knows why that SQL query runs at all. We're going to the magic of SQL. Now, what I'm going to show you here is I'm going to show you some of the basics and try to connect the dots so that you can better understand on how a SQL Server gets the data versus how EF Core gets the data. Because we all know we have here this SQL statement. We have just select star from author where ID equals 1. And we get a simple flat table result. When we do this in EF Core, this gets translated into SQL, but when the EF Core gets back the result, it's not a flat table, it's an object. And this is where the first difference lies. Now, in this particular case, it doesn't matter because they're both roughly the same. But things get different once you start joining tables. And for instance, over here, I'm joining the author with post. Now, what you might see here is we have two William Shakespeares, both with the same ID, and they have two posts. Now, let's add also the tags for those posts, and there's a link table between them, so that means it's many-to-many relationship. A little bit more SQL to write, but what is interesting is this part. Now you have 5 William Shakespeares of the same author ID. We have a couple of duplicated post IDs as 1s and 2s, and you know the tags over here are all unique. There could be some of them the same if they use the same tag for different posts, but what here is important is once you have relationships that are one-to-many, the one part of the relationships might start to duplicate. And I think this is something that we all know, but like to forget. And that sometimes have consequences, which I'm going to talk about a little bit later. Now, in EF Core, things are roughly similar when we're talking about one table. And here I just wanted to show this just to show you when you do this, it gets converted into parameter. Now, what that is interesting is in EF Core 9, you'll be able to make this as a constant, no longer as a parameter, like wink, wink, new feature. So instead of having this as a parameter, you would have the actual number. Now, is that a good idea? Most of the cases, no, because if the number changes a lot of times, the SQL Server can optimize the thing to work really well to target different authors. But if it doesn't change a lot, you can get some sneaky performance gains. But let's not talk about this now. But let's look at what happens if we do this. So this is an implicit join, implicit include. How many of you know implicit include? We have a couple of hands. So what this does is essentially like a left join. It tells it we have configured the post to say author has one-to-many relationships to posts. And now instead of me needing to say, hey, I want to have post, can you include that? I can just say, hey, just give me a post, and I want that from the posts. And EFCO figures the things for me. Now what you find here is, here we have simple left join. Anyone who knows SQL, they'll be like, yeah, checks out. Others will look at this one and was like, hey, what's with this? And this is where a lot of people come to me and say, well, I don't like SQL because it puts a lot of random SQL, especially the select statements. And I was looking at that for a while as well, and I was like, why does it do that? Until I started to read about it. And I also used ChatGPT to verify with it. It's like, hey, why would anyone do that? And then the answer was surprisingly simple. If you take an author and say the author have 10 columns, and you might get 100 rows, right? If you do from author and you directly join into post, you're dragging all of that in. Now SQL Server might optimize it, say, oh wait, I don't need all of that, but now you're relying on SQL Server to do the optimization for you. Now what EFCO does is it optimizes the query for you for SQL Server, so that SQL Server doesn't have to figure out how to optimize the data that it needs to left join. Essentially, it pre-filters all of the rows and columns so that the left join operation is less expensive. And this is why you have lots of select statements. How many didn't know that? Almost the entire room. So yes, I didn't know that either. And when I read about this, I was like, now it makes sense. So yeah, pre-filter before joining. And here I have an example of, hey, I want to add tags. Now the really cool thing about EF Core is this is technically many-to-many table. So I would have to have an additional table in the middle to actually be able to do that. But because I said, hey, this, I said to EF Core, hey, this post has these tags and it's a many-to-many relationship, solve the problem for me. And it solves the problem for me. So it still can solve all of the things. Now you'll look at this thing here and say, oh God, what is this? But the thing is, it's the same principle as here. The only difference is that we just have a lot more columns once we join, once we do this internal join. So it tries to pre-filter as much as possible, but the end result is that the SQL is looking less good. But the thing is, this supposed to work really well with larger data sets, with lots of columns, lots of rows, and it basically also de-stresses a little bit of SQL Server because SQL Server now understands what you want to achieve. So is this a good thing? Well, the thing is, this is generated. So hopefully you'll never be able to, never need it to see it. But yeah, once you have to debug what is going on, it's not that great, but you can always use ChatGPT and usually it can simplify it for you so that you can better understand what EFCO tried to do. But I figured that there's not enough discussion about this, but more people geared toward this being a good thing than not. But this is kind of the problem with EFCO community, not EFCO community. It's more like people who use EFCO and then just say, I'll just use Dapper or just use raw SQL instead of look into it, because we don't have these discussions of, is this a good thing? Because if it's not, how can we make it better, right? So I'm hoping that if this is not good, let's discuss why it's not good and how can we make it better. Yes, there's a question?
Very quick question. That the indenting and formatting of the SQL query that you see there,
Yes.
is that as it's generated by?
Correct.
Okay.
Yeah, I did. This is literally a screenshot. And you can see also I use, most of the queries have TagWith. And I use them intentionally to remind people that feature exists. Yeah, here, they're link tables. You don't have to worry about it. You just tell EF Core these things are many-to-many relationship. And it will create the post tag for you. And some of you might know explicit includes. How many know explicit includes? We have about half a room. Now, the thing is, they're identical than implicit includes. But the difference is, what if I remove this part, but don't change this part? You'll still get a very identical SQL. And this is why I always say, if you can avoid explicit includes, avoid it. Because if you use explicit includes, it's your responsibility to remove them when you no longer need it. But when you use implicit includes, it's EF Core's responsibility. And there's a good chance that EF Core will figure out whether you need it or not more frequently, more correctly than you. Yes?
There is actually a not so obvious consequence of the includes, because includes cause eager loading. EF Core will generate one query and fetch all the data from the SQL server. But if you don't use the select without includes, and then you reference the fields that might have linking tables for, there will be another SQL query within the AF Core to fetch that data.
Yeah, so that wasn't a question, but more of a statement. I'll try to summarize it for the audience. So if you do explicit includes, it can lead to eager loading, right?
It will be just that query that will fetch all the data.
Yes.
And it's called eager loading.
Yeah.
But if you are fetching entities without like those selects that select specific fields, and then you try to query their fields that link to other tables, that will generate another query.
Okay, so that is lazy loading. And
It would be lazy loading.
yes, in EF Core, it's by default disabled. Yeah, in fact, they made it painful to add it, and I love it. There's literally no instructions on how to enable lazy loading, but you can find instructions, and it involves downloading some NuGet packages, doing some configurations, and I'm just like, the more painful you make it, the more I love you. Because yes, lazy loading is painful to debug, and once we went to EF Core, there's just no concept of it, and yeah, it's perfect. And this is why, for instance, when going to your point, you had some unpredictability in entity framework, the classical one, where you fetch some data and all of a sudden you just get some random SQL requests going on. In fact, these ones were happening even in EF Core 2.0, 2.1, and 2.2. They almost eliminate them completely in 3.1 and at 5. It usually will tell you, no, I cannot execute this query if it cannot do it in one SQL statement. You have to do something really terrible in order to execute more than one query. So yeah, it used to be a point, but now it's been fixed. Not to say that if you really try, you still can do it, but it's really hard now.
Okay,
Yeah.
Just to be clear,
Yeah.
that's the opposite of what EF6 was. Like EF6 was lazy loading by default.
Yes.
And then in the patch release, they included the ability to turn off lazy loading, so you can opt in turning it off, whereas EF Core is lazy loading off by default.
Yeah, I think that lazy loading is the reason why everyone hates EF.
Rohan is a shift. That's what they were commenting. There was supposed to be someone here to advocate for lazy loading, but they haven't arrived.
That's a good one. Was that audible?
So the thing where it complains if you've got more than one query
We're going to get to that point.
No worries.
Because now I'm trying to get, now I forgot this one. Okay. To get back to track, so what is the main difference between the data, how we look at the data in SQL and EF Core? This is like oversimplified. We're not talking about binary structures and stuff like that. But just if you look at logically, we have a table that is essentially a flat structure, flat table. And we have some duplications in it. Now, I'm talking about duplications, a really bad thing. Most of the cases is not. But once you have like too many joins, or you include columns that have too much data, then it can be a very big problem. But if you use them smartly, duplication is not too much of a problem. Just not to give anyone impression that never duplicate data in SQL. But the big difference here is EF Core works more like a list, an array of graph structure. So you don't have any duplication. So the way the data is stored is very different. And this is why there are sometimes big differences on how we do queries, like how link queries work opposed to SQL queries. And I'm going to show in a bit a very big difference between one very misunderstood SQL command. List of graph structures. But first, I'm going to talk about data redundancy. Now, sometimes data redundancy is a big problem. Say, what if each post is about 1 megabyte long, right? We have here 3 posts. That's 3 megabytes. And say this one might be 2 megabytes, so we have 4 megabytes. We're downloading a lot of data. Now, if this is like internal connection on Azure, that might go like a snap. But now imagine that you have hundreds of posts, and all of a sudden you have a big problem, like gigabytes of transfer required just for a simple query like this. The simplest solution, of course, would be, why do you even need content? Drop the table. Drop that column, not table. That would be terrible advice. But sometimes you need that data, right? And the answer is not, just use EF Core, it will solve your problem. It's, you can just use separate queries like this. And you solve the problem of data redundancy. You just fetch from each table the data you need. Simple, right? And it works. Might not be the 100% the most efficient code, but if that is the problem, that will fix the problem. Now, the problem here is, well, it's super easy. You don't get any data redundancies. Imagine how would that look like when you need to map that back to .NET or any other languages. Imagine that it's not 3 tables. Imagine there are 8 tables. Now you'll need to not only manually map every single result of the query, now you'll have to basically reconstruct the entire graph structure, which, it's not difficult, it just takes a lot of time. And in the end, if you do this for performance, you may end up not having better performance. Like in the cases that I find personally biggest performance using this approach is when your SQL Server is underpowered and nobody wants to upgrade that SQL Server, and you're like, look, I can spend on this fixing the problem and it will cost you more than upgrading the SQL Server. And they say, yes, please fix it without upgrade. It's like, fine. So in that case, that will help a lot. And there's also other cases where math goes against you. You need to fix it. But in EF Core, what we can do is we can just use the same query and sneak in a split query. Now, what you'll notice here is I'm not changing anything about mapping. And the cool thing about it is, voila, we have split queries, almost for free. Now, some eagle eye will say, hey, these things are here not necessary, why you have them, and yes, please talk to the EF Core team to improve that. But also, SQL Server will probably also notice that, hey, you don't need that, and optimize it for you. So maybe it's not a problem. Who knows? That's why I want to talk about this. Like, is this actually a problem? I wasn't able to find the answer to that, so I'm actually asking, is that actually a problem? And the cool thing here is, like, this is one line change, right? I added one line. All of a sudden, if the SQL Server is underperforming because it has too little memory, or it's downloading too much data, there's too much latency, whatever. One line, push it to production, see if the performance is better. If it's not, you revert that one line. How much does it cost to make one line change? Question?
Is there performance differences within the process by using the split queries? Because obviously, if you're splitting the queries on the server, it might make it more performant for the server. But does that shift extra load within the process itself?
So the question is, what is the performance cost of the split query in a sense from .NET or SQL Server perspective? This is a very interesting question. I usually notice that if the infrastructure isn't a problem, splitting query will usually end up being slightly slower, just because now you're adding additional delay because of needing to execute more queries. But as soon as it becomes an either infrastructure problem, or if the SQL Server is underpowered, you could have 100 times faster on SQL Server. This generally also improves the performance on .NET end because it does require less parsing, and therefore it requires less memory allocation, and also needs to track the IDs and stuff like that less. So yeah, you might notice I am intentionally avoiding to give you any silver bullets, because once because once you get into the nitty-gritty and you're trying to find the best solution, you'll find there is no silver bullet that can solve any problem. It's just the best solution you can find so far.
Just various considerations.
Yeah, for the
comment here is the split queries trade query execution overhead with bandwidth.
Yes. Yeah, I treat bandwidth as infrastructure. It's an infrastructure problem for my...
Too many stars, man.
All right, so it can drastically improve performance. As I said, in underpowered SQL servers, you can see hundreds of times performance gains. Or if the memory requirement or CPU requirement to execute those queries is insane, this could actually get it to a point where SQL Server can kind of execute it comfortably instead of... sorry? Yeah, network throughput. So this is the problem. Like, when you solve these kind of problems, you have so many variables. It's network, it's bandwidth, it's latency, it's how much CPU your SQL Server has, how much memory it has, and even when...
process as well. It's not just
yeah.
database size, but how many resources your application has.
Yes, how much resource your application has. Like, there are cases where I showed, hey, here I have database with 7 million sales. I can get you those 7 million sales from the database into .NET application within, I don't know, 10 milliseconds. No problem. .NET will suffer though. 7 million is a lot to take the full table. But then I can make a SQL query that does some filtering on the SQL end with the same amount of data, and now all of a sudden SQL Server is taking 5 seconds to complete. But once .NET gets the data, .NET's like, bang, done. So if you have a problem where both platforms don't have sufficient power, you can then load balance between them. You can, if you understand how you can, for instance, with split queries, you can offload a little bit the peak performance that you need on the SQL Server, and it may take a little bit longer to transfer. Or for instance, if SQL Server is underperforming in terms of queries, you can just return the whole thing back to .NET. And now you offload the compute on the .NET. And sometimes that can be faster. And you can mix and match. So there's no one way of doing it because it depends a lot on the environment. But here are the tools of how it can help you solve those problems. But yeah, as I said, performance depends on many factors. And it's no more, it's like really, really true when we're talking about server applications and database servers. I think that is the most notable parts where you can see, especially when your database grows in size, you will notice how you just upgrade some things on SQL Server and all of a sudden your .NET application suffers, you upgrade the .NET application now runs really fast, but now SQL Server suffers. It's like an endless juggle of balancing the load. All right, but the good thing is usually when you do split queries, you don't get too bad results. Usually you don't get much worse result, yeah. All right, group by. How many of you think that you know how group by works in SQL Server? We have like 6 brave hands, 7 brave hands. Okay, let's see how you go by. So when we're talking about SQL group by, we're actually talking about summarization of a group. We're not talking about actual grouping, because it is actually possible to process things as a group, but a rule of thumb, in majority of the cases, you end up with a summary of the group. You can do like inline selects and do some things, but in the end of the day, you need to flatten the group. Now, the problem that I often see is EFCO group by actually works like a group by. Like it actually groups data. And when you do group by, say, authors by country, what it will do is just like, oh yeah, I'll just select all of them and order them by country. And you're like, where's the group by? Well, the thing is, here I have a couple of things, yeah. So when I run this group by, I can now for each it. And now I can also say, yeah, for this country, we have these authors. Now we actually have a group of authors by country. You could argue that the EFCOS group by actually works as intended. It's not a summary of group, it's an actual group. But we can leave that semantic in, actually there is on application insight, if you go to the log and you use WCL, there's actually group by, and then it's summary. And that summary converts that WCL's group by into SQL group by, which I love. That literally tells you, yeah, if you want to have SQL group by, these are the 2 keywords you need to use in tandem. Now, what if you actually want to use a SQL-like group by? Well, what you need to do is you need to summarize the group, that it flattens into one line. And voila, we have group by country. So if anyone had the idea saying, hey, EFCO doesn't support group by, it does. Just not the way most people think it does. You need to summarize it. And I was also guilty of that because I didn't know that for too long. But I learned the hard way, and now I know how to use all of that. Now, the funny part is, this actually worked in EF Core 3.1. It did not work in EF Core 2.2 or earlier. It did work in EF6, but differently. And if you mess around too much, it will then do extra queries that it shouldn't be doing, but it kind of worked. But now it works. All right, now here is a bit of a part of shenanigans, because actually we did a little bit of shenanigans before, but this one is actually a part that I was intending to do for separate talk, and I decided, hey, what if I just added in like a teaser for, what else can you do with EF Core? Or better yet, do you actually know how to do this in SQL? Because I'm finding that some people struggle to write EF Core queries because they would not be able to write it in SQL either. And they learn how to write it in SQL once they realize they don't know how to write it in SQL. But then they don't translate that knowledge back to EF Core, which I think it's sometimes the root cause of all of the issues. So how would you get top 5 expensive products and top 5 cheapest products as one query? Does anyone know the answer? No hands? I'm a bit disappointed now. You? Union, yes. And yes, now you have union and you have union all. The difference between union, let me highlight here. The difference between union and union all is that union tries to wipe away the duplicates, while union all keeps all the duplicates. And on top, we're selecting top 5 expensive ones, and at the bottom, we're doing the cheapest one. And we also try to filter not to include 0 values, because I didn't want to have 0 values products. And we merge them together with union all. And we also do sorting by price. And yeah, simple, right?
Does it count as one query when you use union all? Well, there's one database all.
Well,
But if you have 6 union alls, which I've seen before, is that 6 queries or 1? Right?
well, you're getting one result back, don't you?
I just want some of that free stuff.
Free stuff? Yeah, there's some. The database is CellsDB. It's being used. This has 7 million records, and I use it to basically show what happens when your database starts small and then grows out of control. What are the consequences of it? And most of the people say, "Oh, that's why you do pagination." And it's like, yes, that's why you do pagination.
So is the correct answer only have 5 products?
That would also solve it if you only have 5 products.
Less results too. You only have 5 results, same information.
You could also go with less, like if you have max on min, one max and 1 min, you can also solve that problem.
What if you're in the pound store and all the products at the same price?
In pound store, and
In the pound store, all the products at the same price.
if all the products are the same price, yeah, that could be a little bit of a problem. Yeah, but another thing that I want to point out is also this. We have 1 for expensive, 0 for expensive, which allows you to filter then out so you can know which list this belongs. And the reason why I wanted to show you this is because concat exists. How many of you knew about concat? We have a few hands. How many of you knew that concat actually is union all? No hands. I thought so, because when I discovered that at NDC Portal, somebody showed me group join, and I was like, what is a group join? I was like, I never heard of that. I looked at the documentation, and there is a tiny thread that shows that group join may work in EF Core. I'm not talking about that it works. I'm talking about that there exists a possibility that it may work. And when I went to union, I went to concat, I went to all of the other link queries, and I was like really curious which things actually work in link. I was like, most of them don't even mention EF core. And then I was like, what if I try to use them? And I found a surprising list of things that work that zero documentation, nothing. Anyways, simple, right? We concat them, we get one query.
We have a SQL statement in the comment.
Nice. I appreciate your participation.
That be one query
Yeah.
against the database too?
Sorry?
That what we saw there, is that one query against the database too?
Correct. So I haven't shown the query, but if anyone is interested, I have actually linked pad. We can play around after this. But the query is very similar to this one. Like,
DBA in the comments is done in a single query with ranks.
yes, that is true unless the price is identical. When prices are the same, the rank doesn't work. So, yeah, I tried that one. Sorry?
You had a different query there in link to code. So you had order by descending first and then select. And for the second query, you had first select and then order by descending. If you go to the
I might have swapped the order. Yeah. That's possible. Yeah. But the thing is, I do use expensive equals true, expensive equal false. Whether did I make a bug of swapping the order by? Yeah, maybe it's a bug.
affects the query a little bit.
Yeah. Yeah, possibly. Yeah, but it's all easy fixes. But the thing is, here I'm doing order by prices. Technically, I wouldn't need to because there's 10 elements. You can do this in memory very easily. And you anyways need to traverse the entire result set because you want to split out the expensive and not expensive one. So, yeah. 5 minutes? Oh, no, wait.
I'm just asking you a question.
Yes.
You got plenty of time.
Okay.
In the old days of EF6, I haven't used EF since EF6, so I'm scarred by the scars of EF6
I can fully understand anyone who is scarred by EF6 and my condolences.
and previous versions. But in the old days of EF6, a query like this sometimes would execute as one query on the server, and sometimes it would do multiple queries and then fall back to in-memory on the .NET side.
Yes.
And cobble together the result sets to make the object graph you're talking about.
Yes. Now,
How do you know when that's happening in EF? Do you know when that's happening in EF Core, or you got to look at the profile
Yeah.
to see what's happening?
okay, so the question is, how do I know if this is not going to accidentally run more than one query? Because, yeah, that's a very legit question. Rule of thumb is you'll get an exception. Because EF Core from 3.1 is very harsh by default, telling you, no, I cannot do that. It requires you to use as enumerable, which basically explicitly tells you this is now in memory. But there's a caveat to that. The input to this concat is IEnumerable. And I'm not 100% sure how they actually resolve that, because in theory, the way everything works in EF Core, when you convert iQueryable into IEnumerable, it gets resolved.
Yeah, if you put a to list on after the tag file,
Yes.
would that fire off another query before?
Yeah.
It's not an IEnumerable, it's
Yeah.
IDB async enumerable actually.
Yeah.
That is why it knows it's a database call, a database.
Yeah, there's a bit of magic. I haven't fully went deep into to discover that magic, but yeah, it's this from just looking at documentation should have happened in memory, but it doesn't, because everything that anything that converts iQueryable to IEnumerable should usually be processed in memory. And here are the exceptions to the rules. You mentioned that if it's it can recognize the IEnumerable type and
As a IDB async enumerable.
Yeah,
So
I-
if that is like an IEnumerable, but it implements other interfaces which are if
yes,
specific, it may be able to process this at the
Yeah.
SQL server.
yeah, it likely tries to look inside of it if it's IDB.
Faster,
Yeah,
whatever.
enumerable. The tricky part here is that most of the API that are meant to be used by EF Core has iQueryable inputs. And these ones don't have that, and yet they work. So this is one thing that maybe we need to open up a conversation with EF Core team and say, can you please add an iQueryable overload so that we know that it's, we can actually use it with EF Core? Because literally just random people say, hey, I tried this, I have issue with that. And I'm like, wait, your issue isn't that this actually works? Your issue is somewhere here? I was like, how did you even try this? I never thought this would work because the input is enumerable. I wouldn't even thought of that trying. And this is the problem that I'm seeing. And before, I'm going to show you a slide that may not exist yet in the world, and hopefully will exist in many places. How would you get title of books and post as a single result? Say you have two different tables. One has books, you have a column name, and one you have posts, which you have column title. How would you return them as a single query? There's no relationship between them. There's no connection between them. Nothing. The columns are different. Yes?
It's not concat again, is it?
Yes, it is concat.
Let's bring up join.
Yeah. String.join, I think it might not work.
If you listed it first, you could.
Sorry?
If you did two lists first.
You could, but then you don't get one query. Unless you could download the entire database with a single query. That would also fix it. But yeah, the answer sneakily here is union all. But the reason why I wanted to show you this particular case is because if you say this is a different column name than in post, but I can use as title, and now these two data structures are the same. And I can then say here book as type, post as type, and now I can make them as a union, and technically it runs as a single query. And this is how you can get data from two different tables that have no relationship between each other in one single query.
So this is how you load your entire database in one query, right?
That could potentially work. I haven't tried it yet, but in theory it could work. Yes, another question?
If you're ending up in a position where you're writing queries like this,
Yes.
doesn't that point to bigger problems with your schema design? Because it feels like that's a hack to cater for some poorly thought out architecture.
Yes, generally, but then you have reports where it's like in all of the cases, these two are separate entities, but then you have one report where you need to treat them the same. And I have a very good example of that is invoices and credit notes. They're very different beasts, but there's one report that says, I want to have both. And we're like, why? And then we discovered union, and it's like, okay, fine, you can have them. But that's the, yeah. That's the only place where we wanted. We were thinking about, abstracting and doing whatever with a database and schema and EF Core, but then we realized why we would put all of that effort for one report, one query.
Sometimes
Voila.
it's control schema.
Yes.
Sometimes it's someone else's database that you have to play with.
Yes. We have a question over there?
Well, more of a comment, sorry.
Comment, yeah.
Like sometimes you have two different entities that aren't modeled as having a relationship.
Yeah.
And you kind of implicitly have things in common, and then you realize you want to query over the things that, as a single data set, the things in common between those entities, and this would be a really cool way to do that with very little effort, right?
Yeah, I'll try to summarize what you just said. We sometimes have two similar tables that functionally are different, but they have a lot of similarities. And sometimes we do want to have them treated as one thing in very rare cases. Yeah, like what we have with invoices and credit notes, literally just one.
There's heaps of examples of that.
Yeah.
Just invoice and credit.
Yeah. Generally speaking, if you happen in this situation too many times, you probably should fix your schema. But if it's like there's one report or two reports, you can have many reports as long as you don't have to run them lots of times. If it doesn't functionally impede your application, especially if you're doing database replication, where it doesn't even impact your application if you run in performance queries and nobody cares if the report takes 5 seconds versus 50 milliseconds, then it might not be a problem that needs to be solved. Anyways, here you go. This is the EF core, actually nice and neat. Now you can get data from 2 different tables in as a single query. And the good thing is I'm showing you SQL first because that's pretty much almost identical what you get with this query.
The
Yeah.
other way around.
Sorry?
In the SQL query.
Oh yeah, I might have swapped that. Yeah.
This title here, its name.
Oh yeah, that's true. As I said, this part is like I wanted to give you for this audience here something new that I haven't shown on NDC Sydney. I haven't shown to all of the others. I wanted to do that. Unfortunately, I hadn't had enough time to actually make it look good. But I hope that this might actually open up some options of, not just in how you use EF Core, but also how you can use SQL. And I'm not telling that this is the most optimal query. There's, for different scenarios, it might be there might be better solutions. But if you need it, that's how you can do it. And I think this is the slide that is missing in the internet history, where it actually can tell you what EF Core methods gets roughly translated in SQL, like join, for instance, .join actually is an inner join. So that means that if something is missing on the other table, you'll just have the entire record missing, which is different from, say, implicit or explicit include, which is why I'm understanding why we had some bugs in the past, and also ask how some code actually worked, because now I understand it shouldn't work. But I was junior back then, so I blame the seniors back then. Then, of course, union is union. The difference between concat and union is that union tries to eliminate all of the duplicates, where union all keeps all of the duplicates. Question?
Your previous examples used concat everywhere, but since you had a literal in there, union would have worked the same, right?
It would work identically. Like, for instance, when we had top and bottom prices, the expensive and the cheapest, if we only had 5 elements or less than 10, the union is actually going to trim the access, which may have unintended consequences, because now you'll have, say, 5 expensive and 3 cheapest, which might be what you want.
You've got an explicit literal of 1 in the expensive and 0 in the
Yes.
They can't be trimmed against each other.
Good point. It might not be trimmed because we're adding an additional unique column. But if we wouldn't have that column, then it would be trimmed. But then, yes, you wouldn't be able to distinguish if it was trimmed except by the size of it. But then you could also have that many. Yeah, good point. Then we have intersect, which basically, I wanted to have a picture over here to show you. I think I have in the downloads. Did I download that? Yeah, here. And I have link path of this if anyone is interested. It's such a small. Yes, I'm enhancing. So yeah, intersect is this little piece over here is basically what you have in the left and the right table, and except is what you have only in the left table. So what is the difference between union, intersect, except opposed to the joins? The joins technically are one data set against another data set. I know that some database people are going to say, no, you're wrong. But from the SQL Server perspective, it's like you're just trying to merge two different queries rather than results. That's the way I most easily explain myself what's the difference. You're not joining the data, you're joining the queries. Also, if you're putting them underneath. Yeah, like when you join the rows. When you do unions, intersects, and unions, you put them, you add columns. Yeah, you add rows, sorry. In join, you add columns. Yeah, so horizontal is join, vertical is union, intersect, and things like that. You might not notice, but I actually never started to be database person. I started to be database person with EF Core 2.1. That's where my knowledge comes from. Yeah. So I started to appreciate SQL because of EF Core. And this is why I'm so excited to talk about these things. And this is literally the thing that I have seen nowhere in the internet. And the thing that actually put me on this entire journey is this group join. Because a random person at NDC Porter said, hey, I have this issue with the group join. I was like, group join? And I was like, yeah, it's like, group by, but it works almost like a join. It's like a mishmash of those. It's like, I didn't know that existed. And we debugged together and stuff like that. It's like, that's oddly, it was very familiar. It didn't work like a join, didn't work like a group by. And literally yesterday, it clicked. This is the left join. And not just left join. This is exactly what the implicit and explicit join does. This group join is if you want to do the include part manually. It took me years, but I figured out yesterday that's what it is. Or at least from the testing that I have done, I managed to consistently get the same SQL result when I did the semantically identical code between using group join and the implicit or explicit includes. So yes, if you ever need to do that explicitly, group joins. Now you can do that. Sorry? So I just used the colors from the Azure Data Studio, just because it looked nicer. But in retrospect, there might not be enough contrast.
It's an inline select or a left join or an out. The is black.
This is just my text. The bolded ones is the actual SQL statement. Yeah, so if anyone wants to more geek out, like I have actually managed to do a temporary table in EF Core and managed to select into a temporary table and then managed to query out of it, all in EF Core with some shenanigans. Yes?
Is there a way to do a full group join? So
Group join?
Yeah, the full group join, so both sides.
So full group join. I don't know. Probably. But yeah, if anyone wants to see more shenanigans, I can show it after talk, because I want to, also if you want to see this in action, I actually have a few demos I can just quickly run at the end. I just want to go to the last part, which is indexing, because this part is the thing that everyone knows you should be doing. But most EF Core developers, when they say, hey, what if I do indexing? The database people say, no, I'm not going to let you do that. Or they say, why would you use EF-Core for that? Just use raw SQL or things like that. It's like, I understand why there's a little bit of reservation, because it's not well understood how EF-Core deals with indexes. And this is where I want to demystify a little bit, to also put the database engineers a little bit at ease that, EF-Core can actually create indexes and use them, especially because everything is happening on SQL Server end, not on EF-Core. EF-Core just says, here's the index, here's the code for for creating it. Can you please do it? And then SQL Server does all of the job. Now, if you want to learn a lot about this performance, database performance, there's someone who is a lot smarter about this, Brandon Oliver, about this topic. He does this a lot. And I think he had a session here as well at some point. So you might have a recording of that as well. Listen to him. He will explain you why you want to have indexes, the consequences of not using indexes, and lots of caveats. What I'm going to show you is the bare bone introduction into indexes, how you can use it, how you can figure out whether you're actually using the index, and how you can fix some of the easy stuff. So you will be better prepared for it. So why do we need indexes? The simplest answer I always get is performance. And then they stop. So performance. All right. So we are only going to talk about unclustered indexes, because when I did the explanation for clustered indexes, they said, yes, maybe focus on unclustered indexes. Your explanation is fine, but the EF-Core part still needs a little bit of work. So I'm preparing that part for later, because there's a lot more on clustered indexes than I thought there is. But clustered indexes are like primary keys. Well, they are primary keys. And they usually tell you how physically the data is stored in the database, in what order it gets stored, usually. And in EF-Core, primary key is used by default as the clustered index. Now, unclustered index is something, and usually you can only use one per table, the cluster index. The unclustered index, you can use multiple per table, which is why it's a more interesting one for EF-Core developers, because they don't have to figure out what would be the most perfect cluster index. They can just figure out what would be good couple of cluster indexes. Yes, you can. The best way to explain what indexes are is almost like if you're adding a copy of the table, but the way you create the index. So if you say, I want to have an additional index with just that one column, it almost is like creating an additional table aside of it.
It's a lookup. It's not an additional table. You're not copying the table. You have a lookup.
Yes, lookup is a better word for it. Yes, that's the word. I think I'm going to use it. Yes, I was talking to a lot of people. A lot of people tried to explain to me what it is. I kind of understood what it is, but nobody used the word lookup, and I'm like, that's the perfect word.
It's like an address book.
Yes.
You're looking for this, and address it where it is in the table.
Yeah, most of the people explain it in a way like it's an additional table. So here we have a query. Now, how do we figure out what index is being used? Now, actually first, how many of you know about indexes or use them? Okay, majority of the room. How many of you know how to use them in EF-Core? This EF-Core? We have only four hands. Okay, so I'm going to show you how to use it in EF-Core. But for those who don't know how to verify which index you're using when you query data, what you can do is you can enable actual plan over here. And what you get is this query plan over here. It gives you like a little graph, and this part over here will tell you which index it's using. So if you have PK author, that's usually the primary index, and that means that you're getting the whole deal. And
If you mouse over it, you also get a bunch of stats.
yes. Yes, if you mouse over, you'll get a lot of stats, like how many rows it took out, the size of the table. It even gives you what it estimated it would get versus what it actually get, which is very interesting because I ran quite a few SQL queries, and the estimates were really accurate.
You can also suggest indexes.
Yes, you can also do, and I actually have a query for suggesting indexes. Although a lot of database people told me, please don't. Ask me first. All right. So yeah, I'm very strong in development that tries to learn as much about SQL, and I'm learning every day how much I don't know about it. And while a lot of people compliment me on the knowledge of the SQL Server, they tell me one word, and I was like, what is that? And then I spend a whole day figuring out how much more I don't know. Okay, so here we have the most simplest index. What I'm doing is on entity author, I'm adding a index country. And what this does is it creates this IX author country. That's the default naming convention in EF Core. And when I do select country from author, instead of doing the query from PK author, it now does from IX author country. So this is now the lookup table where it has only the country and, if I remember correctly, also the primary key, so that it can then link them together if that's required.
By default, clustered index.
Apologies, I couldn't hear you.
Default is clustered index or unclustered?
This is unclustered. Yeah, this is unclustered index. Yeah, you can do primary keys in EF Core, and by default, if you do ID or the entity name ID, it will make it as a primary index, but which usually is good enough. But if you want to optimize that, I think there's like Bryden can say that this could be like an entire session just talking about how to optimize the primary key. And when I listen to it a little bit, I'm saying, okay, I'm just going to focus on unclustered indexes. I'll let you deal with the clustered indexes as a separate talk, and I'm going to link to yours, and then I'm just going to tell you how to create that in EF Core. This is where you want to have real database people on board, and they'll just tell you, I need this, and then you're just like, I'll take this, figure out how to do it in EF Core, and then you have a really magical database. All right. Now, where we can get problems is, what if you do select name country from author? What happens is, I think I missed the spot, but it now goes back to PK author, which is the full table. So yes, now the index that we have created before is no longer used. And you're like sad because you were super happy about adding the index. You thought, yay, I won the day. And then somebody adds, what if I add name? You think, yeah, that's fine. And then later on you realize it's not using.
From 1 second to 15.
Yeah, yeah, and you're super sad. But you know what? You can solve that problem. You can do include properties. So that is not a clustered index. That is only adding that additional data to the lookup. So it doesn't get the benefits of being an index.
It adds this data to the leaf nodes of the index.
Yes.
Stored as a tree.
Yeah. So here, now with the same query, you can see that we have IX author country. So now we are back to the index that we're creating, and the query is fast again. Nice, isn't it? Yes, question?
Sorry, just clarifying my understanding of this. So if you go select name, that
Yes.
will be a table scan because there's no index on name.
Yes.
So if you go select name country, it then can go and use the index and pick up the included property.
Yeah, so here what we're saying is
The name
include,
is included in the country index.
yes, include this data so that it can be part of the index.
I think it will become part of the index, but not as a key, but as extra fields.
Yes, it's an extra field rather than index. Yeah, so it doesn't have the benefits of being an index. It's just an additional data that is attached to the index. And
Otherwise, it has to look it up itself. Now, because it is an extra field,
yes.
it has to look it up again.
Yes, so that's the thing. Like, if your database have enough column, to my understanding, it may prefer your index over the primary key, but you have no control over it. SQL Server decides which path is better. Like, if it decides that your primary key is, your index is a better decision, then it will take it will take your index, take what it needs, and then make a join with the primary index table, and then fetch the additional column. And Bryden actually demonstrated that in his video, in what cases that happen. But this is outside of your control. In my case, there's too few columns, and what SQL Server decides is to ignore my index.
Well, to be fair, you can actually hint the SQL Server to use a specific query length for those.
Yes, you can also hint that, but Bryden also said that SQL Server can ignore the hint. It can, yeah, SQL Server can be temperamental when it comes to indexes.
The other one is indexes are not query-based.
Yes.
They are table-based, so they are kind of semi-permanent between queries.
Yeah, it's basically giving SQL Server tools, and then on how it can query the database. But SQL Server is ultimately the one that decides how it's going to query the database. You can only give them additional tools to guide it toward where you want it to be. Okay, so we have that. But sometimes, a question?
Do you want to talk about why that might not be a good idea to add extra fields at all?
I mean, yes, we can quickly cover that, because I am a bit curious about that. Sorry, the question why it might not be a good idea to add additional properties, there's columns.
I've seen developers being tempted and they just add 10 columns or 15 columns.
Oh yeah, the developers might just add lots of columns into it, and then you have a big mess.
Because that increases the physical size of the index, which may take even more space in the database than your table.
Yeah.
Plus, if there is a limitation on the size of the leaf nodes, so it has to fit in the SQL table page. So you can't include too many columns. It will take space, and it will be eventually slower, and SQL Server may choose to ignore your index for that reason.
I would have loved to have that on microphone, so I'll try to summarize that. So what you're saying is that if we're adding too many columns to an index, the size of that index can actually be bigger than the original table, and you can actually cause more performance issues than solving them. Would that be a good summary of it?
Yep.
Yeah. We have a few more.
It's also, like, I'd be worried about adding indexes too much too soon, because like early on when you're writing your code and you're designing what you're doing and what query, the query that you queries that you think are going to be happening early are likely different to by the time you go to ship to production. So
Yes.
if you're thinking too much about your indexes at the start, you might likely end up creating all these indexes have maintenance costs.
Yes.
There's overhead in inserting, updating, deleting, everything like that. With every extra index, there's extra overhead. So maybe don't do that until the end and you've profiled your application, see what the heavy queries are, and then do your indexing.
Yes. Yes, premature optimization is a really good answer to that. And to summarize, your answer is
Don't index too early.
don't index too early, because you might do indexes that will actually cause more harm than good. What I would say here is if something is extremely obvious that should be indexed, like you do a lot of date sorting or filtering by date, probably good idea to add it. Otherwise, if anything is like, I can squeeze a little bit more performance out of that, probably not a good idea.
It depends on the profile of your table or database as well, because indexing increases query performance, but it slows down the insert and update performance, because SQL Server would have to update the index as well.
The insert and updates and probably also deletes get all impacted the more indexes and the more complex indexes are.
It's common here that a normal index is a dictionary key pointer, whereas pointers refer to pointers refer to clustered index, where an index with includes is more like a dictionary of key to a list of pointers and an array of extras. So
Okay, I'll need to process that.
I'll copy you on that one.
Okay, cool. I'll take yours and then we'll move forward.
I think my colleague here almost covered it. Every time you update a row that has name in it, you need to do a write to the table plus a write to the index, which is also carrying the name.
Yes, yeah.
So you end up, if you add a lot of these, you end up in a bit of a hole.
Yeah, the way I'm looking at this is if you have a table that doesn't update much, it might be an okay idea to add more indexes, but if something updates like frequently, probably split up into more than one table and then try to solve that with a better database schema.
Some of this can be solved with like read-only replicas and like read-only copies of the data, so you're not actually writing complex queries against where you're storing it. It's actually going something that's already pre-calculated into a separate table.
To repeat that, we can store that by using like read-only replicas.
Yeah, read-only replicas or a read model of the table.
Yeah, read-all model stuff. Yeah.
That matches the query a little bit more closely.
Yeah, although I think all good things, but I'll try to get back to EF Core. All good discussions, and I think this is why I love to do this kind of things, even though everyone says, why don't you do raw SQL? Because I think EF Core currently isn't as good as it could be, because we're not talking about these things and how to make it better. And yes, it is an ORM, which by design should have certain limitations, but I also managed to bypass quite a lot of limitations that ORM's supposed to have, just because somebody gave me a good reason to make it work. And I think we can, and also in general, ORMs are not being able to supposed to modify things directly in the database. And from EF Core 7, you can do that. You don't have to get the data into the .NET, modify it, and save changes. You can just say, in this table, under these conditions, modify these columns. In fact, you can even say, take the data from that table and modify it. So you are getting to a point where you can start doing things that you will only able to do with Dapper or raw SQL with built-in EF Core functionalities, and we can only do that because enough people said, this is the reason why I'm not using EF Core. And if we have more conversations like that, we can make it better. One last question, and then I'll go to the...
That's the reason I use Dapper all these years instead of EF, is because I want to be able to do exactly that.
And you can now do it.
Where ID, set
Yeah, you can now do that. And I think that's the yes. And I think that this is why it's important to have these discussions, because these discussions are the things that make that happen. And if you want to have a composite key, this is how we do it. So the main way of knowing whether you're having a composite key opposed to have just multiple columns is it attaches country name at the end. Otherwise, in the previous one, it was just the country. And yeah, you can see we have the same query, and you have that. Now, in most of the cases, this probably will be faster, but if you attach too many of the indexes, you might end up in trouble.
Recalculating indexes will be a little bit more expensive.
Recalculating indexes. I assume that if you do not change a lot the database, like in case of authors, it would not impact too much. But if it, yeah. Yeah, and this is where, you really want to have a conversation with your database person. Say first, yes, I'm using EF Core, and I came to you so I can understand how to make a good index. I can do that in EF Core, but I need your knowledge to make a good decision. And we can make it work in EF Core.
And as developers, we can be database people as well, right? They're not
Yes.
mutually exclusive.
Yes, the developers can also be database.
DBAs might disagree.
Yeah. Yeah. But I also think like 30 years of experience in the database can give you insights that you would never thought of, whereas a lot of developers, especially the ones that are coming currently from uni, if they know SQL is already a lot sometimes. And now we're asking them to create indexes.
An ORM saves you from writing code. It doesn't save you from understanding what's happening under the hood.
Yes. And
an ORM makes your code maintainable.
Yes.
With raw SQL, you've got magic strings and stuff. So an
Yeah.
ORM is all for maintenance and making it nicer.
Yes, EF Core is really nice for maintenance because, for instance, if you have raw SQL and say you decide, oh wait, I made a bug, this shouldn't be named, this should be actually title or I don't know, full name, right? What happens when you try to change that to full name? Now you may need to go through all of your raw SQLs, manually rename the things, and what if there's more than one table that uses name? If you do replace all, you might accidentally change one too many. And if you use Dapper, I think Dapper has ways of bypassing that a little bit. But again, there's no way of strong typing. And EF Core really allows you to do these changes really nicely. It's not perfect in data migrations, but it does give you the tools that if it messes up, you can actually fix and do your own SQL in the migrations. So if you don't like what it does, you can fix it. And I think this is one big thing to think about is the cost of maintenance of the application, the cost of training the new people who never use SQL Server, who maybe the only experience they have with the database is an ORM. And teaching them, all of these magical things about databases, and then pushing that into production where the database is like really, really business. It's really important. Like if anything goes wrong, big problems. With ORMs, you can avoid a lot of these issues because there's very little they can do before they need to actually start messing with the entities, and then they need to create a new migration. Otherwise, EF Core is going to tell you nothing works, I refuse to run. And then if you review the pull request, it's like, why did you create this migration? It's like a lot more controlled change, and you can allow the application to grow more controlled, but that doesn't mean that you cannot leverage the full power of SQL Server. It just means that your power to SQL Server can be a bit more managed. You can choose when you want to gain more power from SQL Server opposed to have more maintainability. And I think EF Core gives you that balance of when I choose which of the extremes I want to go, because it allows you to go in any extremes you like, as long as you know how to do it. And the only tip I have there is like, as long as you have a good argument for that, and you can then justify it with someone who is going to wake you up in the middle of the night saying, what the hell you were thinking, go for it. Yes?
Yeah, beware if you rename a column in a migration.
Yes?
If that column was included in the index itself will not be renamed. And it will be named as the previous column name.
I heard that. So if you change the column name, it actually won't rename the index, and you might have problems with that.
Oh,
Yeah.
not the problems, but like matching the index name to the columns.
It goes through a lot of steps to do column name migrations. So
Yeah. Yeah,
it's
it's...
a question of, like you go to a DBA user group and they're still trying to understand source control.
Yeah. And I love this because I haven't had this many good conversations about that, and mostly it's because I love the people that are really strong with certain technology, and I also notice it with myself. We are really, really tied to our tools that we love, and what I want is that we are a little bit more open to see how we can mix those tools together, because I think that mix gives us the best results. Because as you've seen earlier, like the split query, that feature, literally one line, can save your business, because you might have underpowered SQL Server. It's a physical hardware that you cannot upgrade. What are you going to do? You're going to refactor a query that is overcomplicated, spend a few hours, then you need to debug it and all of that stuff. Or you're going to say, hey, let's try a split query, see if that is like the emergency patch that at least allows us to breathe. And these kind of features actually can, save your weekend. Yes?
No, I was just sort of saying.
Yeah. Okay, so if you want to know how to do good indexes, although a lot of DBAs tell me, please don't, without asking me first, you can go to things like Azure, and it has the performance recommendation. The reason why you don't always want to just jump your gun is because it's going to give you the good performance recommendation for right now or for the last 10 days. And you might have just a freak accident of lots of people coming and doing a certain thing, and it's going to try to optimize it for certain thing that may never happen again. So take with, my DBA said, with big pinch of salt, with fistful of salt. You wanted to add anything?
Yeah, to the previous slide. You can also define indexes using data annotations on your entity objects.
We can also define indexes on data annotations on the indexes. That's in the on entity. Sorry, yeah.
So if you don't want to use model builder.
Yeah, yeah. We can use annotations on the entities. I kind of like the model builder just because I can show it a little bit easier. And you have then all of these definitions there. Okay. If you don't have Azure, you can run this query. It can work, so you don't need SQL. There's also a URL there. If you need screenshot of that, I can give you later. And on Azure, you're starting to get Copilot with Azure SQL. Last time it was in private preview, so I haven't have access to that. Yeah, this thing, and yeah, that's the summary. And I'll add you just one bonus thing, which I kind of alluded to that. This came with EF Core 8, And this is something that I was just like, when I noticed that this one Canadian guy, Jean-Sebastian, I'm butchering his name, we met in NDC London, and we geeked out about a lot about EF Core, and then he sent me tidbits like, hey, did you know that you can use EF constant in the, I think it was EF Core 802? I was like, okay, why would you use that? And it's like, have you ever had a query that in production was super slow, but then when you put in SSMS, it was really fast? It's like, actually, yes. It's like, for instance, this part, like select 1,000, and then you have this thing here, and this is really fast, and then you have a code like this right here, and it's really slow, and you're like, but it generates almost exactly the same query. But it actually doesn't, because this top 1,000 becomes a parameter, this 1,000, right over here. Now, the problem here is that this is kind of a constant, right? Because it's just one or the other. But until EF Core's 802, you weren't able to define constants. And this can actually have a staggering performance impact. Now, parameters are good, but not always. And in this particular case, it was really bad. And this is how the syntax was suggested, and I believe they didn't implement it in 802. I think they implemented it in 803 or something like that. So I think this is now working, and the difference can be staggering, because if anyone knows the parameters in SQL, if you use them right, it can have massive performance differences. All right, so you have links to the Git issue if you want to look into that, the code sample, lots of resources if you want to look into it. I forgot to hide that slide. Thank you.
There was one other thing for that page.
Yeah, yeah.
So it would not be a parameter, it would be a constant if you pass a literal constant there. It only parameterizes that if you pass a variable into that link query.
Yeah. Already froze a little bit.
All good?
Yeah.
Yes.
Yeah, thank you.
Okay.
Thank you very much, JK. I think that prompted a lot of really, really good and informative discussion from the group tonight. Another big thank you to our sponsors, SSW, for providing us the pizzas and the drinks, and the JK. Next month, we have Marique from Xenix, I think it is. Yes. Coming to talk to us about Blazor. Sorry, other sponsors to thank is Telstra Purple for providing us with this great space, which is always appreciated, really good. We have another sponsor being JetBrains, who provide us with give us a voucher every month to give away to someone of JK's choosing. It gives you access to one of the JetBrains products. So, do you have the folder? Yes, we have the folder. Is there anyone you would like to give the voucher to?
You've done a lot of.
I don't. I have all the JetBrains products.
Yeah, I think, like, I got like a lot of conversations today, and I'm very happy for all of the feedback.
Do you have a JetBrains?
Yeah. Okay.
Does anyone not have a JetBrains?
Okay, first, raise your hand who doesn't have JetBrains. Okay.
I'm having a winner. One person in the whole room. You've got to get that on the stream. JetBrains. Everyone already buys your product. I mean, keep giving us vouchers, please.
There's like 20, 30 people here, and only one that didn't have JetBrains.
Would anyone else like a JetBrains? There we go.
Oh my God, have a jet.
Well, he does now.
Yeah.
That's only
Data grip, writer.
Yeah, that's only one product. You might only have one product. You might want to get a different product. So there you go.
Yeah.
So big thank you for JetBrains as well for also sponsoring us, giving us these gifts to give out to the audience or the speakers when the speakers don't have them. Again, thank you everyone for coming tonight. Once again, we run the first Thursday of every month We're always looking for speakers and presenters and sponsors. So if you want to get up and even if you want to sponsor, not have a speaker, but you want to get up and spruik your company a little bit because you might be looking for new devs, new engineers, or you might have some new things coming up. We're always open to that sort of stuff as well. So if you have anything, reach out. You can reach to us through the user group, not through the meetup, sorry. So there's Todd up the back there, myself, Turtle, and Cam. We're all organisers, so you can talk through to any of us. We're a pretty welcoming group. We try to cut out any hecklers or anything like that. So, and we can help you to, if you've got an idea but don't quite know how to shape it, we can talk you through that as well. So, yeah. But otherwise, thank you everyone else for coming tonight. See you next month.